Can you see the screen?
Yes.
Okay, so today we are going to continue our discussion and we'll look at database. We'll continue with database with Flask. So in this place, I'm going to create a new file which I'll just call db model.py. This is where we are going to continue with that. So in our usual way, we're going to create import Flask from Flask, import Flask. And then we create an app as an instance of that Flask, pass the name. Okay. And then we also, if name is equal to app.run, debug equals true. Okay, so this is like our normal way of setting up a basic Flask application. But now we want to, add models. So we import SQL Alchemy from SQL Alchemy. Now we need to configure our app for our database. So we usually set app.config, then SQL Alchemy, that's called database, and that's called URI. So this is kind of the location where it will be located. So we are using SQLite. That should be it for the URI. And there's another configuration we may want to set. SQL Alchemy, track modification. So this one is to be tracking the modifications. It's usually true by default, but we'll just set it to false. Okay, now we then create the database and wrap it. Wrap the app. So with this now, we have set up our database. Now this reminds me, before we go forward, let me go back to our last class. which is this, you find out that we set up our database,
Come in.
but there is a challenge now. If we make modifications, if I run this script, I think when we ran it in the last class, and whenever we needed to run it again,
How
come
are
in
you?
and
How
delete,
are
we come and delete the database, to recreate it each time you run the database setup file. You keep doing that. Now, there's an easier way to do things if there is a change, because I could start my creation by creating just this model, and along the line, I want to add another model. The easier way to handle it is using what we call Flask Migrate. Flask Migrate can help us create the database and also update it from time to time when we run the migrate commands. So that's something we've not done, and I'll now introduce it here. So I need to activate my virtual environment also on my terminal. So that's my so it's there. We are there now. Activated it. Let me import migrate. We have Flask Migrate. Import migrate. Okay, so this one, I think we have not installed Flask Migrate. So that's why it's underlined. So now in the virtual environment, I need to pip install Flask Migrate. So it's something you need to install. So pip install Flask migrate. Okay, so Flask Migrate is installing, and we've installed it. And let me just use this opportunity to run this command to upgrade my pip. Okay, now I've installed Flask Migrate, then I have migrate. And to use it migrate in my application, I basically would wrap the app and the DB in migrate like this. Okay, so that's what this line is doing. I set up my migration. Let me do this, and I'll have this for the migration. So we can always create changes along the line and update those changes as we go along. So now we are going to create our models as we've done before. So class, I'll call it child. And it will inherit from DB model, db.model. Normally, whenever I create a model, SQL Alchemy will just name the table in the database with this name of the model child. So the name of this table now in the database will be child with small c. But if you don't want it to be that name, you can always overwrite it by using this done method. So maybe I could have said something maybe children. If I do this, then I'm setting the table name. but I'll just leave it as the default. So no need to change it. Okay. So as we did before, we'll then specify the columns for this table. So it's going to have an ID. DB colon, and the data type will be integer, db.integer, and I'll make it the primary key. Remember what primary key is in the database. Okay, so this our database is going to be the primary key is going to be the ID. And what do we need for this child? We need a name. And the name is going to be another column. Call it DB text. We will not just bother ourselves with other parameters, but you can add that. Then I can say these children, they have toys. So each child is going to have toys. Now, remember we want to talk about relationships. So toys now are going to be items that each child is going to have, but they will be in another table. So what I would declare here now is the relationship between this and toy. So it's going to have a relationship with a table called toy, which is another model, and a backref. That'll be backref parameter. It will be this model. Okay. So what I'm trying to say now, a child, he has the ID, has the name. We could add maybe an age. Let's just add. Let's leave it, not very important. And then it has some items, toys. Now, the relationship here, which we are trying to model, in relationship, it could be one-to-one. One-to-one relationship is maybe one child will have only one toy, one-to-one. We could have one-to-many. One child can have many toys, which in this case, that's what it's going to be. Okay, a child can have as many toys as possible. But when you go to the side of the toy, you find out that the toy normally should have just one owner. So that one now is a one-to-one relationship. But here now, the relationship between this child and the model toy, which is the table toys, is going to be one-to-many. And how we handle it in Flask is we just leave it like this because by default, it's expecting it to be one-to-many. But we'll see what it will be in one-to-one. Okay, so we can just put it there. One-to-many relationship. Now, this should already let you know that we're going to have other model, which is, for instance, toy. This will also inherit from db.model. I'll just put a pass, we'll not implement here. And we're going to have one other model for this class, which will be father. So let's say every child is going to have a father. Remember what I said, there could be different tables in your database. So these are like different tables. So we have a table for a child, which we've defined part of it. Then we can go ahead and have a table for toys, assuming each child has a toy or toys, which is why I say one-to-many. It could be one toy, it could be many. And then we also will create a father. each child is going to have a father. Okay. So we also create some other methods, the init method for this. This init method, what we need to supply when creating a child, we just need the name. Okay. We also create the RAPR method. If we can just say, how do you want to represent it? Because I want us to represent it if hold on, let me put pass now. I think there's one parameter I've not created. So we still will need to have that father represented here. For each child, the column to hold the father. It also has a relationship with the model which I created below, which is the father. We also have this backref parameter. Now, we'll have another parameter here, which is going to be false. So this is the use list parameter. And this is one that makes it because each child should naturally have only one father, right? So if you talk about the relationship now, this will be having to be one-to-one. So this should be one-to-one. A child should have one father. So how do we model this to become one-to-one with this SQL Alchemy of Flask is we set use list to be equal to false. The toys one where we did not set anything about use list, by default, use list is equal to true. And that means you can have more than one toy in the list. But yeah, when we say use list is equal to false, it can only have only just one father. Okay. So the child is going to have one father. So the relationship here is one-to-one. The child is going to have different toys, can have different toys. So the relationship is one-to-many. And now we can go ahead and complete our REPR method for it. So the way I wanted it to go is if self dot father, which means if the child has a father, then we will print it as return. We return our F string. Child's name is, and father's, sorry, okay. Let me use double quotation. Okay. So that I can use apostrophe. Child's name is, I'm going to put it here, self dot name. Okay. And father's name is self dot father. Name. Okay. Child's name is this, the name of the child, and then the name of the father. And father's name is self.father.name because father on his own is another model which we have his name. So self.father.name. Now we then have else. So which means if he doesn't have a father, copy this line. Return, and we do not have his our father's name. So that we can have some children, if we don't know their father's name, whenever you try to view them, it's going to print child's name and we tell you we don't know the father's name. But then when we have a child, we know the name and then the father's name will be printed. So this is the way it's going to be represented. Anytime you attempt to print an item of that model, which is like an item in the class, okay? And then we can also have one more method, which will tell us the toys. What is the child has. And print. So when I go back to toys, remember there is no use list. So toys is going to have a list. That's why we say it's one to many. I can then say for toy in self.toys, I can go ahead and just say print toy dot item underscore name. Now, item underscore name is going to be in the toy class when I write it. Okay. So now let me write the toy class. The same thing, we could change the table name, but we'll just leave it as a default. And it's going to have its own ID, db.colon. This will be integer. And it's going to be primary key. Now we are going to also have item. Let me just toy name. Let me just call it toy name. Instead of item name, I'll call it toy name. Okay. This should be a text. So each toy now is going to have an ID. Now remember what I said that in a database you could have more than one table. So child is one table in this database. We've written some of the details of it. Now we are in this one. So you can see that each table has their own primary key, right? But then each toy is going to have a key that ties it to the owner, which is where I would then say child ID is equal to db.colon. This will be an integer and it's going to be a foreign key. And this foreign key will come from . it will come from child. So it's going to be the ID of a child. So because if the toy is owned by, let me say, a child with ID of 1, then in the toy table, we're going to have that ID. So let me go now, just for those of us that don't really understand the database thing much. Let me come back to this Excel we're just using to share some understanding. So here now we have a child. We don't have sex and age. So let me remove this one. What we have is toy, and then we have father. Okay. But initially, when we are creating a child, we do not need to provide the toys or the father. All we just need is the name. So you can have a child and say the first child's name is Francis. The second child's name can be Joy. Okay. The second child's name can be Joy. So then in another table, in this database, we still have another table, which this time now, let me add a row here just to make it. So let me call this one. This is child table, okay? Just here, just say. Then we have another table for the toy. What do I have? I have the toy name. And then I'm talking about having a child ID. So this is another table. In the database, let me just put it like this. So now in our database, we have 2 tables. So this is what we're trying to do now. In the toy table, you're going to have an ID. Whenever you put a toy, the ID is automatically assigned. So the first toy that will enter the table will have ID of 1. The name maybe is a toy car. So it's a toy car. Then who is the owner of this car? You cannot have a car, a toy, without an owner. Okay, we can't have a toy without an owner. So what are we trying to say is, by the time you're buying a toy, there is somebody that you're buying the toy small for. You're buying the toy for somebody. So it's either going to be Francis or Joy because they are the ones in existence. So let's say this toy car belongs to Francis. In child table, Francis ID is 1. So in the toy table, it will be here 1. So this child ID, remember when we defined it as a foreign key. What does foreign key mean? Foreign key means the primary key in another table. So the foreign key in this toy table now is child ID, which is the foreign key in another table. Okay, so it's going to be 1. Now, if I have a doll, maybe a doll, this doll now, as the second toy we record, it's going to have a child ID of 2. Why? Because let's say it belongs to Joy, or before that, so that it doesn't look like it's just cereal. Let's say I have the second toy is a toy gun. Toy gun. It's still going to be Francis's own. So you see the child ID is 1. So basically what I'm trying to say is that foreign key is how you tie these 2 tables together in the database. So whenever there's a query on toy table, how you would know who owns the toy is through the foreign key. But the foreign key now must be a primary key in another table. primary keys must not be numbers alone, right? It could be text. But one thing about primary keys is that they are unique. In this child table, you cannot have two um, primary keys that are the same. So one cannot be repeated, two cannot be repeated. For each entry, then you have that primary key. It's like a unique identifier of that entry. Same thing with the toy table, you have that one, two, but then it's now having some three. Okay, so it's doll, and it's the two. It's now linking to the owner using the ID of the owner. This way, you could have another person now, another child can come, and the child's name will be Joy. Okay, there are two Joys, but which one owns the doll? It is the unique, identifier that separates them. So with this, now you now know the Joy that owns the, because there's only one Joy that can have an ID of two. In this table, you could set conditions that, okay, no two names can be the same. Like if you had that employee we talked about, and no two employees can have the same email, you can make that column unique, when you're defining your table. Remember, you could also add parameters here, nullable, false or true, and unique, and also, and so on and so forth. I hope it's clear for everybody so far. Okay, so I'll now go ahead and complete the father's table. So every father is not also going to have an ID, also the same thing. It will have its own primary key. Okay. And we'll have name. Okay. So again, one more attribute we're going to have for the father is ID. Whenever you're creating a toy, you must have these two. Okay. We can still go ahead and add an arrow EP arrow method if we want, but then we'll just go to the next. Same thing here. Okay, so we have the three models. We've created three models. Okay. So far, does anyone have any question?
On me, no question.
Okay, so now we can actually run and test our code to see if it's okay as saves. Right now, I'm going to show us how to do the Flask Migrate because we just introduced that into this now. It's going to take care of how we handle our database. So to do that, if you're on Windows, the first thing you need to do is to um, set the Flask app. We now set it in our terminal. In our